There is GATE 2025 problem, forenoon session. One of the question for the construction of a highway, a cut is to be made as shown in the figure. The figure is given. The soil exhibits C prime equal to 15 kilopascal. That is, the effective cohesion is given. Effective internal angle of friction is 15 degree, and the undrained cohesion is also given as 60 kilopascal. Unit weight of water 9.81 kilonewton per meter cube, and gamma T above the water table and below the water table are given as 19 and 20 kilonewton per cubic meter. So the cut to be made and for a highway project, and we have to find the factor of safety against the shear failure at this point A in long term. This is the point A shown in the figure. This is the water table variation. This is the groundwater table. And there is the potential slip circle. So the potential shear failure is also shown in the figure. And above the water table, this height is given to you as 5 meter. Below the water table, the height is given to you as 6.5 meter. So how will you find out the solution of this problem? You have to find the factor of safety. So to find out the factor of safety, the solution, let's see how to solve it. So here, the factor of safety F will be tau F, that is the shearing strength at point A, and we have to find out at point A divided by the shear stress mobilized at point A. So this is the mobilized one. So at A, this is mobilized. That becomes the factor of safety. So how to find out this? And you have to find out for the long term. So in the long term, the pore water pressure dissipates, and therefore the value of tau F at point A, we should calculate. So tau F will be given by C prime plus sigma n, the effective normal stress, and into tan phi prime. So that will be the value of tau F at point A. Therefore, we can substitute the values and get the value of tau F at point A will be C prime is already given in the problem as 15 kilopascal, and the sigma n prime, the normal stress at point A, will be up to 5 meter. It is above the water table. This is your water table. So above the water table, the total unit weight is 19. So 5 into 19, and that is the normal pressure, plus for the remaining 6.5 meter, the soil is fully saturated and it is underwater. So you should take the submerged unit weight. So saturated unit weight is already given as 20, minus gamma W is given as 9.81. That becomes gamma prime. So that becomes the submerged unit weight. So C prime plus sigma n, the sigma n into tan of phi prime, and the phi prime value is already given over here as 15 degree. So this is equal to tan 15 degree. So C prime sigma n prime into tan phi prime. That is at point A. So this becomes, if you simplify it, you can calculate it, 15 So if we calculate this, let's calculate it. 15 plus 58.202. So when you simplify it, sigma, this total value is going to be uh, 10.9 into 10, 15. So 58.202 kilopascal. This is the value of tau f at A. Therefore, tau f, the shearing resistance at point A, is given, and tau immobilized is already given as 60 kilopascal. Therefore, we can calculate the factor of safety equal to 58.202 divided by tau f mobilized will be 60 kilopascal. So the ratio of this, so divided by 60. So this gives you the value of 0.97. So find the factor of safety against the shear failure at this point in long term. In long term, it is less than 1, so it is going to fail. So factor of safety against shear failure at point A has been calculated. This is going to be 0.97. That's the answer. So this question has been solved. Now the next question, we will take it. Now, the second question is like this: the vertical pressure in an odometer increases from 100 kilopascal to 150 kilopascal, assuming the soil to be fully saturated, assuming the soil to be fully saturated and and initially has zero excess pore water pressure. Find the effective stress and pore water pressure. So we have to see the solution of this particular problem, which is has to be calculated. So you have an odometer, you know it, that there is a soil sample and the pressure is initially 100 and then you increase it to 150 kilopascal and soil is fully saturated. So this soil sample is completely saturated. At 100, initially it has zero excess pore water pressure. When you increase it to 150, the pore water pressure will increase. So when the vertical pressure sigma V increases to 150 kilopascal, the pore water pressure will immediately increase. So at time t equal to 0, the moment you increase the pressure, it was 0 at 100, excess pore water pressure, no excess pore water pressure. The moment you increase it, it is fully saturated, so that intensity of loading is going to increase the pore water pressure. That pressure will be transferred to the pore water, which is incompressible compared to the soil grains. So when the vertical pressure increases to 150, the pore water pressure will immediately increase. So therefore, the pore water pressure at 150 kilopascal will be 150 minus 100. At 100 it was 0. So it is going to be, the net increase is going to be 50 kilopascal. So there is the increase in pore water pressure immediately. And the effective stress, therefore, the effective stress is going to be total stress minus excess pore water pressure. So total stress is going to be 150. This is the total stress minus the excess pore water pressure is 50. So therefore, effective stress becomes 100 kPa. Therefore, the effective stress and pore water pressure, effective is going to be 100 and pore water pressure becomes 50. Therefore, the answer is going to be I hope this point is clear to all of you. Now, the next problem is like this. The result of consolidated drained triaxial test. Test on normally consolidated clay. So it is normally NC clay are shown in the figure below. Find the angle of internal friction. The figure is like this. This shows the normal stress in Newton per mm square or megapascal, you can call it. And on the y-axis, it is the tau value or shearing stress in Newton per mm square. And it is given like this. Here, it is 50 and this point is 100. So you need to have the solution of this problem. Quite simple one, because it is CD test, consolidated drained triaxial test. So in CD triaxial test on normally consolidated clay, the C prime is going to be 0. And you have to find out phi prime, angle of internal friction. So if this is the Mohr circle, let's say this is O, this is A, B, and this is D. So C prime will be 0, and therefore this angle will be phi prime, and this angle is going to be 90 degree. So here sine phi prime D, let's say this point is E. So sine phi prime will be perpendicular divided by hypotenuse. So D in this triangle ODE, it is going to be D divided by OD. This becomes the radius. So D is going to be the radius and the diameter is going to be 50. So 50 divided by 2, 100 minus 50 divided by 2, whole divided by 2, that becomes the radius. So it becomes 25, and OD is going to be sigma 1 plus sigma 3 by 2, sigma 1 plus sigma 3 divided by 2. The value of sigma 1 here is 100, sigma 3 prime is 50, therefore sigma 1 prime plus sigma 3 prime whole divided by 2 will be equal to 75 kilopascal. So therefore sine phi prime equal to 25 divided by 75. Therefore phi prime equal to sine inverse 1 by 3. You can do it other way also, second method. This is one of the method. The second method could be, you know, sigma 1, sigma 3. What is the relationship? Sigma 1 equal to sigma 3 tan square alpha. Because C is already 0, therefore this will be the relation between sigma 1 and sigma 3, where alpha will be, or sigma 1 100 equal to 50 tan square alpha will be 45 plus phi prime by 2. Therefore, or tan square 45 plus phi prime by 2 will be equal to 100 by 50, that is 2. Therefore, tan 45 plus phi prime by 2 will be under root 2. Therefore, you can find out the value of phi prime quite easily, the angle of internal friction. So, this is the second method. So, it will be 45 plus phi prime by 2 equal to tan inverse under root 2. So let us calculate now phi prime. So simplifying this, we can get the answer. So shift tan inverse root 2. 54. This is giving you 54.73. Therefore, phi prime equal to 54.73 minus 45 into 2. So this you can find it out. So 54.73 minus 45 multiplied by 19.46 degree. If you take sine of 19.46, you get 1 by 3, that is 0.33. So that is the answer. So either way, whether you use this method or you use this method, you can get the same answer. So this has been solved by two techniques, two methods. Now, next problem. These are all forenoon session problems of GATE 2025. Now we will take the next problem, which is on a single pile. So a single pile with a 450 dia is driven into homogeneous clay layer with Cu equal to 20 kilopascal. Gamma equal to 18 kilonewton per cubic meter, and groundwater table is at the ground surface. So it is touching the ground surface. If alpha equal to, that is the adhesion factor, equal to 0.95, and the bearing capacity factor NC equal to 9, and pile supports column load column load of 144 kilonewton, the factor of safety equal to 3 against ultimate axial pile capacity in compression find the required embedment depth, find the required embedment depth of pile in meter. So let us see the solution of this problem. How will you solve this problem? You see, it is a single pile embedded or driven into the ground. So uniform single pile. The diameter D is 0.45 meter or 450 mm. And the groundwater table is here at the surface, and the value of Cu is 20 kilopascal, and gamma saturated is 18 kilonewton per cubic meter. Alpha and NC are given to us, and it supports a column load. So the allowable load for this single pile is given. Therefore, the ultimate load, Q ultimate, will be factor of safety multiplied by the allowable load. Therefore, the ultimate load becomes 432 kilonewton. So the ultimate load is known to you. Therefore, you can find out the depth of embedment. Let the depth of embedment of this pile is L. So let L be the depth of embedment of the pile in meter. Therefore, Q ultimate equal to, we know the formula, C and C. Here, for a single pi, it is going to be the uh, the skin friction, which is going to operate Fs equal to alpha times Cu. So alpha times Cu, the skin friction, this is the skin friction which is acting over the shaft area. The shaft area will be pi into d, that is the perimeter, into the length. So alpha times Cu into shaft area plus 9 times Cu into pi by 4 diameter square. This is the formula for single pi. Now Q ultimate is 432 and the value of alpha is 0.95. The value of Cu is given in the problem as 20 and pi diameter is 0.45 meter into length, that is the depth of embedment, plus 9 into 20 into pi into d square divided by 4. So let us calculate this. 4.95. This is 26.86 times L plus. Now this becomes the second part. This becomes 28.62. Therefore, by simplifying, we can find out the depth of embedment L. So 432 minus 28.62 divided by 26.86 equal to 15.01 meter. So the depth of embedment, therefore, is calculated as 15.01. So find the required depth of embedment, which is 15.01 meter. This is the answer, and the solution is quite simple. The next problem of gate 2025 of forenoon session is like this. Water flows from P to Q through two soil samples soil 1 and soil 2 having cross-sectional area of 60 cm square as shown in figure below. The flow condition is steady if coefficient of permeability of permeability of soil 1 is 0.055 centimeter per second and soil 2 is 0.035 centimeter per second, then find the discharge Q through the soil mass. The figure is shown here. So you have the soil sample here. This is soil 1 and this is soil 2. The water is flowing through this. So water flows from P to Q through two soil samples, soil 1 and soil 2. The cross-sectional area is given and the coefficient of permeability is given. The length of soil 1, L1, is given as 50 centimeter. And for 2, L2, soil 2, it is 30 centimeter. Then, and the water level is here shown. And here the water level is like this. So the head loss delta H is shown as 150 centimeters. So head loss is also shown to you, and you have to find out the discharge Qs. So how will you solve this problem? Quite simple one. So the solution of this problem has to be the discharge Q will be, now you have got two soils and the water is passing like this perpendicular to the bedding planes. So two soils. So K equivalent into I, that is the hydraulic gradient, into the cross sectional area. Cross sectional area is given to you. Here, the hydraulic gradient will be loss of head when the water is permeating through the soil samples, two layered soil, and perpendicular to the bedding planes. It is going to be delta H divided by the length of the sample. And delta L is already 150 centimeter and length is going to be 50 plus 30, that is 80. So I is known to us, cross-sectional area is already given as 60 cm square. So this is known. This we have calculated. Now K equivalent we need to calculate. The K equivalent, if I consider this direction as X direction, it will be X1 plus X2 in this direction divided by X1 divided by K1 plus X2 divided by K2. So the X1 here and X2 are known to you. It is L1 plus L2. So it is going to be 80. So K equivalent therefore can be calculated. So if you calculate the coefficient of equivalent coefficient of permeability, there is 50 plus 30, that is 50 plus 30 divided by 50 divided by K1, and K1 is given to me as 0.055 centimeter per second plus X2 here is 30 divided by K2, and K2 is already given to me as 0.035. So if I simplify, I can get the value of K equivalent. So this will be also known. Therefore, from this relationship, I can find out the discharge. Let us calculate. So 50 plus 30 becomes 80. So if you calculate 80 divided by it is known, it has been calculated that K equivalent in centimeter per second is 0.045 to cm per second. So now substitute and get the value of the discharge. So the value of discharge, therefore, Q, that is the rate of discharge, equal to K equivalent, that is 0.0452 multiplied by the hydraulic gradient that has been already calculated as 150 by 80, so 15 by 8, and uh, the cross sectional area is 60 cm square. So now let us calculate into 15 into 60 divided by 8. So the answer is calculated. The rate of discharge, therefore, is 5.0955 centimeter cube per second. So Q value is this one. So this is the discharge and this is the answer. Friends, rest of the problem will be calculating in and showing you in our next video. Thank you very much.